Thank you all for coming. Can you hear me decently? Can you hear me from here? Okay, great. So just a quick show of hands. How many people are pretty familiar with the Bitcoin system? Okay. And how many people are pretty familiar with how Ethereum works and how it differs from Bitcoin? So reasonably good. So 50% maybe. Okay, so I'll go over in a little bit of detail what the differences are between Ethereum and Bitcoin. Essentially, 3-4 years ago, a smaller group of people were getting excited about the decentralizing technology that is Bitcoin. And many people felt that in addition to the core use case of transmitting and storing value, that there were potentially implications for many different use cases in many different business niches or verticals or political systems or social systems. So there are a bunch of different projects were attempted, different approaches were attempted, colored coin approaches, several of those, meta protocols around the Bitcoin platform. Some people stood up their own networks that were not Bitcoin and played with different solutions. Vitalik Buterin, who basically invented the whole Ethereum concept, was working on a few of those projects and basically realized that people were, really smart people were having too much trouble building generalized applications onto the Bitcoin protocol. And so he took a step back and said, instead of trying to add some features into the Bitcoin protocol, it makes sense to build a computationally complete virtual machine and install that at every node of a network. And that white paper in November 2013 was how Ethereum was formed. So a bunch of us got together, and in January of 2014, I guess 8 of us declared ourselves founders of this project and announced the project at the Bitcoin conference in Miami. On July 30th, Ethereum version 1.0 launched itself effectively. So a bunch of developers built 1.0, and Ethereum, it's essentially a feature complete version, even though it's not quite scalable and probably won't be for a couple or a few years. And the Ethereum Foundation didn't really create the Ethereum network. We did create the software, but in order to, for legal reasons and philosophical reasons, it made sense to gently nudge different groups around the world to use a particular version of the Ethereum software with certain parameters. And essentially, many people around the world constructed their own Genesis blocks based on a recipe that they were given, and fired up the client that they downloaded. And we all watched in amazement as this tool, which embodied a new organizing principle for humanity, organized itself into existence. So 6 months later, there's a lot of interest currently. There's a lot of interest in different enterprises in building on private, semi-private, or public versions of Ethereum. And like Bitcoin, which gained a lot of attention based on the price of the token and based on the total size of the monetary base, this sort of activity is starting to happen for Ether and Ethereum. Currently, as of very recently, Ethereum has overtaken Litecoin and Ripple to be the second largest cryptocurrency-based platform behind Bitcoin. And so I think it's a market cap. I think it's around $200 million right now. So the Ethereum project built the world's first general purpose world computer. Its dynamics arise from a synergy of 5 different components that it shares with Bitcoin. These components fairly quickly are the blockchain, which is a decentralized shared database system. It's shareable in terms of data and stored procedures or functions that operate on those data in the form of smart contracts. It's shared between all entities on the system that maintain their own local copy of it. And so this sort of data structure enables different groups and different organizations to share data and share programs and trust that there is no central authority that is improperly manipulating the data, or no system administrators or CFOs or hackers are messing with the system, and you can verify that because everybody maintains their own local copy of what's going on. The second element is a cryptographic token. Not much difference there between Bitcoin and Ether. Third element is a peer-to-peer networking system. Turns traditional client-server architectures into peer-to-peer architectures where everyone's a client and everyone's a server. The consensus formation algorithm is different in small degrees from the Bitcoin algorithm. Essentially, it is currently a proof of work mining algorithm based or optimized for GPUs. Bitcoin is currently optimized for ASICs, which leads to the potential for centralization of the ecosystem. And as part of Ethereum's scalability plans, there's a 2-phase process. First phase will be moving to proof of stake, which I can describe later if anyone's interested. And the second phase is sharding the address space. Both those projects are about a year old and both have prototype code written. Peer-to-peer network system, they're quite similar between the two projects. Consensus formation and the virtual machine. In Bitcoin, the virtual machine is very simple, and it supports a simple programming language that you can't do much with other than send transactions between different addresses. There are a few different ways of doing that. On Ethereum, it's a computationally complete virtual machine. And this enables sophisticated applications to be built by average programmers within the full security of the protocol. So unlike Bitcoin, where you can share the data, but not really the behavior, not really the programs, on Ethereum, you can craft an elegant data model and store that on the system in the form of software objects, and you can attach behavior to those software objects, and all of that behavior and data is shared. So these 5 components constitute a global computational resource. It's non-repudiable and censorable. All the good things of Bitcoin, plus a whole bunch more functionality. If we add to this blockchain-based computational resource other systems, especially decentralized storage systems or mesh networking, you get essentially a world computer. So it's a shared substrate for building global economic, social, and political systems. So Ethereum version 1 is largely feature complete. Scalability, as I indicated, is underway, and scalability is probably the winner-take-all holy grail. So the first project that achieves real global scalability is likely to dominate for the foreseeable future. Bitcoin has some scalability solutions in the form of lightning networks, side chains, a couple others, but it's likely that Bitcoin will achieve some scalability, but probably not. Probably have to become sort of back-end network for financial transactions rather than being able to scalably subserve a large number of transactions. So about 15, 16 months ago, it became clear that we were going to achieve our goal of building this world computer, this decentralized World Wide Web. And at that point, I formed Consensus to build decentralized applications. The initial intention was for us to be a dApp boutique. But because we were very early, we had to build our own versions of the protocol effectively. So 2 implementations, the Haskell implementation and the Java implementation, were developed independently of the foundation and built by people in this room. Roman's one of them. Kieran and team are the others. And because we were early and trying to build decentralized applications, we built a bunch of developer tools for rapid application development and testing and blockchain explorers, etc. So a decentralized application is a set of smart contracts that serve as a shared database. And these smart contracts serve as your back end. A front end can be command line, it can be a web application. dApps are essentially building a decentralized application involves writing, debugging your smart contracts, then injecting them into the public Ethereum blockchain. At that point, they are effectively assigned an address and are deployed within seconds across the global network. And then to interact with those things, your user interface generally forms a transaction, and you sign that transaction and inject that transaction into the network. So that means that basically every implement or every time a program on the system is used, it's done so through an authenticated and a granularly authorized transaction. So it is potentially a much more secure infrastructure for building IT systems. So Consensus and many others are building a bunch of components at the application layer of the ecosystem. Some of these components are a wallet and an identity and persona solution, which we're turning into a KYC platform, a multifaceted, multi-layered reputation system, registry system. So we've built Regis, a registry system, and there are a couple others in the space currently. We built a token issuance and management system. We built a token exchange system. We're working currently on stable token systems, so working to enable a US dollar token. We're working to enable a handful of other things that would be considered stable tokens. There is a system for gluing Ethereum networks to other Ethereum networks or to the Bitcoin network called BTC Relay. We're using that to enable atomic swaps between Ether and Bitcoin, or to enable payment on the Bitcoin network for services on Ethereum. And that can potentially serve as a way of creating a Bitcoin token on the Ethereum platform. So on these core components, we built a handful of applications. One is a triple entry accounting system. If we have time, James will be describing a demonstration of a total return swap that stores the transactional data in our triple entry accounting system. We built a smart document creation and management system. So you will soon be able to select clauses. Some of those clauses can be self-enforcing smart contracts, and assemble those into a document. So it could be an employment contract or a total return swap. We're building a decentralized threaded discussion system, or a decentralized Reddit. We at Consensus are trying to take decentralization seriously, and so we are in the process of putting almost in the process of putting some governance of our own organization on the blockchain. So Nick Dodson has written a governance system called Boardroom. We intend to use that at the hub level of Consensus, as well as for many of our different projects, so that they can be quasi-independent projects. We built a crowdfunding system, total return swap, obviously. We built a handful of platforms also. So some of you may have heard of the Ujo Music platform, which is a prototype for artists to register content. And essentially, once they've registered content, particularly on this platform in the form of music, they can attach usage policies to that content, and the rights to use that content in different ways based on policy flows to consumers or other artists, while the value for the use of those works flows to the artist and is automatically split amongst all collaborators as specified by the artist. Built an event and community management system. We were supposed to play our first round of Ether poker tomorrow, but it looks like it's delayed a week, so that will probably be the world's first provably fair decentralized poker game. We built a loan platform that's not quite operational, but it's getting pretty close. And we built, probably the last thing I should cover, we built an architecture for open energy markets, which we're also applying to a community-supported agriculture community. The energy markets platform was designed to be the decentralized business logic layer on top of decentralized energy generation, storage, and transmission infrastructure. And so that project is going on in a Brooklyn-based microgrid, and we are in discussions with the European utility to extend some of that work more broadly. The architecture that underlies both platforms, agriculture and energy, is a resource generation architecture. Generators in the form of photovoltaic arrays or farms produce resources, kilowatt hours or apples or potatoes. Those resources can be tokenized, and those tokens can be sold into the market and then redeemed in a spot market for delivery of electrons or delivery of apples. Those tokens or other tokens representing futures and options on those tokens can be also issued by the generator or other entities, and those can be used to provision your supply of energy or food for a specific time period. All of these can be traded on a decentralized exchange, so the tokens that we've issued in our token issuance and management system are recognized by the wallets that we built and the decentralized exchange that we built. Eventually, it is likely that, at least in this Callicoon area, north of New York City, it's likely that they will implement a decentralized energy infrastructure and a decentralized community-supported agriculture platform and enable the trading of kilowatt hours for apples or potatoes. Let me stop it there, as we have a couple of interesting things to run through. Kieran's going to demonstrate block apps, which is one of our infrastructures. We packaged up a bunch of tools and put them on the Microsoft Azure cloud for one-click deployment of private enterprise blockchains or private consortium blockchains. So some of their tools, some of Roman's stuff is on Azure and available for use. Kieran's going to maybe talk about that a little bit and also walk you through the creation of a smart contract using the infrastructure that the Block Apps team has built. So, thank you. Okay. Any questions about Ethereum or? Go ahead.
Can you talk about the kind of utopian-esque feel to an energy transfer on a platform like this? I'm just kind of curious what
Utopian-esque feel of energy transfer on a platform like this?
Like,
it seems pretty utilitarian to me.
Fair enough.
Yeah, I think I would have trouble answering that. Other than the energy industry is decentralizing because the infrastructure is vulnerable and brittle and wasteful. So you have a lot of. Yeah, sorry. So the energy infrastructure, the physical energy infrastructure, is decentralizing quite naturally. It's getting much less expensive to generate and store energy, store electricity in particular, and that is a phenomenon that is sweeping the world right now, and we aim to enable that by creating business models that are decentralized. So I guess there's the utopian aspect, perhaps, so that we don't have to continue with businesses that are centralized while effectively, potentially trying to slow or stop the decentralization of generation and transmission of excess energy short distances, maybe across the street. Yes, I guess it is a little bit utopian to have everybody generating their own energy and sharing it with their neighbors efficiently. Good.
Hi. Has there been any more development with Ether wallets, hardware or software?
Wallets. Yeah, sure. So the Ethereum Foundation has built Mist, which is intended to be an Ether browser. So something into which you can load a user interface which accesses smart contracts that are on the blockchain. It has a built-in wallet, and you can load decentralized applications into it. It's not super smooth yet, but it's very usable currently as a wallet. We at Consensus have built a handful of different wallets. We've built a client-side browser-based light wallet, which a bunch of our different decentralized applications are going to make use of that when released.
I'm thinking of something simpler, like I'm familiar with Bitcoin wallets, using their wallets.
Yeah.
I'm thinking something simple like that. Let's pretend I don't know how to develop a decentralized app.
Sure.
I just want to store it in Ether.
Yeah, so you can simply download the Mist wallet from the Ethereum Foundation. It's pretty elegant. CryptoKit released an Ethereum wallet. It's a group based in Toronto. So that's also client-side browser-based.
Thank you.
Sure. Go ahead.
You mentioned that, like in the future, something can happen to the contract. We're working on a project right now of almost. We were reading a little bit on the Ethereum alarm clock, but say you have a trigger in the future, like on X date, you trigger something and say make a document declassified. Is that possible yet? To have a future trigger on them without a human interacting with that trigger?
Yeah, so currently for version 1 of Ethereum, in order to get something to happen in a smart contract, you have to ping it. You have to send a transaction to it with some data or some command. And there are, as you're probably aware, there are Oracle mechanisms that can ping contracts for probably version 2 or maybe sooner, probably version 2. It is slated that a cron mechanism will be built so that you can basically set an alarm clock in a smart contract.
The sending and receiving of goods represented by tokens is super cool, and that's something I get. But would there, or do you foresee a way to be able to send, say, substantial amounts of encoded information via Ethereum, images, large text files, that sort of thing, or would it always need to be purveyed by a third party and verified by the contract?
Sure. So a couple issues there. One is that data storage on Ethereum in the unscalable version is very expensive. So you don't want to upload music or movies or anything to the blockchain itself. And we use a system called Interplanetary File System, or IPFS, to store large blobs of data, and that can be hashed up, and the hash, which is also the URL, basically can be stored in a smart contract. When scalability is achieved in version 2.0, where you've got subsets of validators processing subsets of transactions in each time frame, then it is expected, in combination with moving to proof of stake, that it will be much, much less expensive to run computations and store data on the system. So maybe a lot more use cases for storing more data on Ethereum 2.0. Good.
Would you speak more on proof of stake versus proof of work in Bitcoin? You mentioned you might say something on that before.
Sure. So proof of stake is the first component leading towards scalability. Essentially, proof of work is a system that is expensive to run and wasteful of computation and energy and hardware. The one thing that's really good about proof of work is that it is a good initial issuance mechanism for your token. If you start with proof of stake, which is basically where people who have a certain amount of that token have earned the right to process transactions on the platform. If you start with that sort of system, we couldn't come up with a good issuance model to issue the tokens fairly and widely. And so we chose to issue tokens by selling them for Bitcoin initially and sold them in 9,000 separate transactions. And then we figured, the real reason we chose proof of work was because we weren't confident enough in proof of stake, and we knew proof of work worked. In addition, it was thought that running proof of work for 12 months or 18 months or 24 months, however long it takes to get proof of stake finished, is another really good way of disseminating the token. Proof of stake in conjunction, it'll work in conjunction with sharding, but essentially proof of stake enables you probabilistically, depending on how much of your ether you've staked compared to how much total is staked, it enables you to be chosen as a set of validators to process transactions for a specific block. Any more? Go ahead.
Have you been talking to regulators at all, and how's this been perceived?
We have talked with a few, and so far there's no pushback. There's just a lot of interest and excitement about enabling better foundations for financial infrastructures and other infrastructures. So we're building a triple entry accounting system, and that sort of thing enables real-time comprehensive audits, enables real-time risk metrics and sensitivity analyses. It enables movement of compliance into smart contracts rather than a head count of compliance officers in each organization. The cost reductions are potentially enormous. I think regulators all over the world and in a variety of niches are extremely interested in what this kind of infrastructure can enable. One more? Go ahead.
The concept of sharding is like truly incredible. Are you also collaborating with Vitalik and Vlad on that front a little bit?
Collaborating in that I cheer them on, yes. So we talked about sharding in our first gathering in January 2014. We all rented a house together in advance of this announcement at the Miami conference, and yeah, we talked about sharding back then, but it started getting worked on after that, about a year after that. Okay.
I'm just curious about the triple entry accounting. That's not decentralized, is it?
It is, yeah. So you've got one company with their double entry books on the blockchain and another company with their double entry books on the blockchain, and either journal entries in their books are linked in a transaction or they're linked in a smart contract. So you can imagine a business process being embodied by a smart contract where let's say it's a purchase and sale of something. You could have an offer in an email or on the internet, acceptance of the offer through signing, a cryptographic signing, down payment, invoice issuance, bill of lading issuance, tracking of the delivery, potentially all the way through to warranty issuance and servicing. So all of those things, like any business process you can imagine, can probably be embodied in one or a set of smart contracts. And effectively, instead of firing papers and emails around and having phone conversations, you can have all of your documentation accessible by all the stakeholders in that transaction. And the transaction is controlled as basically a state diagram, basically a set of state transitions with maybe some exceptional conditions. You probably won't be able to get everything right in the first business processes embodied in smart contracts, and so probably want to have exceptional mechanisms where if a situation arises, then you default to the legal system or some sort of arbitration system.
Question?
Go ahead.
Start developing and testing contracts. I assume you have to purchase Ether to do that, and is there any restrictions about that in New York?
So there are no restrictions. Well, you can purchase Ether in New York. On certain exchanges, you would have to submit documentation. There's one exchange called Shapeshift that believes you shouldn't have to submit documentation. They're based in Switzerland, and you can buy amounts of Ether for different tokens like Bitcoin. In terms of getting started writing and testing smart contracts, you can just download the client and build your own private network. So that's how almost everybody, must be everybody, does it. It would be kind of foolish to be developing on the public network. It would get very frustrating because you're waiting 17 seconds for blocks. Whereas if you're using one of a variety of systems that are designed for development, it's much, much smoother. Sweet. You good? Okay. Thank you.